Hi, hello everyone. How are you all doing? Everything going good? I hope I am perfectly audible and visible to each and everyone present over here to watch this particular session. Okay, anyway, warm welcome all of you to the YouTube channel of Infinity Learn by Sri Chaitanya. It's me Surya, your chemistry faculty for this particular session. Today in this particular session, we are discussing the new chapter, that is redox reactions. Okay, let us see what is the weightage of this particular chapter in the JEE Main exams. Okay, the redox reaction that chapter came in the JEE Main exam around 4 marks, which means the weightage of 35% is here. The chapter is very important. The major topics we are covered in this particular chapter is oxidation and reduction, types of redox reactions, balancing of redox reactions, and finally redox reaction, the application in the electrochemistry. Today in this session, we are focusing on the basics of the redox reaction, that is what is oxidation as well as reduction. Clear? Without wasting time, let us go to the topic first. Okay, I have a question for you. What do you mean by a redox reaction? Whenever you see or hear about the redox reaction, what is come in your mind about redox reaction? For example, if I am splitting these redox reaction into two types now, it will written as red or ox, right? Red and ox. Here, the red stands for reduction reaction. And ox stands for oxidation reaction. Which means that redox reaction means the reaction that contains oxidation as well as reduction. Right? Before going to the explanation of oxidation and reduction. Hi Sudha, good evening. Yeah, fine. Redox reaction means reaction which undergoes both reduction as well as oxidation. Clear? Okay, before going to the explanation of redox reactions, we will just moving to the simple topic, that is the what do you mean by oxidation number or oxidation state? Okay, what do you mean by the oxidation number? It will be the simple charge, right? Otherwise, we can say that the residual charge present in any atom in a molecule, present on any atom in a molecule. This is known as the oxidation number or oxidation state. For example, if I am taking an ion here, for example Na+, what will be the oxidation number or oxidation state of this particular ion? +1, right? Because it is Na plus ion, the charge on the particular atom is +1, which will be the oxidation number of this atom. If I am taking another example, for example Mg2+, what will be its oxidation number? Yes, great. +1. Here it is Mg +2, which means +2 will be the oxidation number, right? And also there is a term you have to importantly noted that somehow we are using oxidation number as well as oxidation state interchangeably, right? Which means that this is not exactly same. Oxidation number and oxidation state are different, but we can use oxidation number interchangeably with oxidation state. If someone asks you about whether oxidation state and oxidation number are same, you must be say the answer like that these are not same, but we can use it interchangeably, right? Clear? Now, I have already mentioned that the residual charge or formal charge present on any atom in a molecule is termed as its oxidation number or oxidation state, right? If I am giving a molecule, for example, I will write here. Okay, if I am taking an example here, for example, this will be our molecule, HCl molecule, right? In the case of HCl molecule, how we can calculate the oxidation number? That is discussed here, right? The algebraic sum of oxidation numbers of all the atoms in a neutral molecule. HCl is considered as a neutral molecule, and here the algebraic sum of oxidation numbers of all the atoms is taken as 0. For example, if I am considering the HCl molecule, which means that here the algebraic sum. What do you mean by algebraic sum? The sum including signs, right? Plus minus. Whenever we are adding the magnitude along with sign are normally known as the algebraic sum. For example, if I am taking, generally hydrogen has the oxidation state of +1, right? Then chlorine is the halogen having the oxidation state of -1, which means that the algebraic sum of these oxidation numbers is +1 plus -1, right? That is equal to 0. This I already mentioned here. Clear? Gamis, I don't know more about the Hindi. My Hindi is not that much good. I will explain in English only, right? Okay. Now, whenever we are considering any species as an ion, if I am considering the species as an ion, what will be its oxidation state? It will be the algebraic sum of oxidation numbers of all atoms should be the simple charge on the atom. For example, here if I am taking CO3 2 minus, here the algebraic sum of oxidation state of carbon and 3 oxygen should be equal to the charge on the atom, that is -2, right? For example, for carbon, if I am taking 4 minus 6, what will be the charge? 4 minus 6 minus 2, that is similar to the charge on the atom. Clear? Hi, hello, good evening. Is the thing clear? Just let me know. Whenever we are discussing about the oxidation number of different atoms or molecules, there are some rules you have to keep in mind. First one, the oxidation number of an alkali metals and alkaline earth metals. What do you mean by alkali metals or alkaline earth metals? I have already discussed in a chapter, right? Periodic table. Thanks for your compliments. Okay, what are the alkali metals and alkaline earth metals? Which group elements are known as the alkali metals and alkaline earth metals? Yes, alkali metals is group 1 elements, right? Group 1 elements, and alkaline earth metals are known as the group 2 elements. Here we can say that the oxidation number of alkali metals is +1 and alkaline earth metals is +2 respectively. Clear? Now, second point you have to note that whenever any element which is expressed in their elemental form, its oxidation number should be taken as 0. Elementary form or native form. For example, if I am taking hydrogen molecule, right? H2 molecule, which means 2 hydrogen atoms are bonded together to form a diatomic molecule, H2 molecule. Similarly, if I am taking another molecule like Cl2, O2, then for example P4, which means phosphorus molecule, right? In the case of P4, 4 phosphorus atoms are combined together to form a tetraatomic molecule, right? Similarly, in the case of S8, if I am taking gold, Au, right? These all elements are in their elemental form or native form. For these particular elements, we will take the oxidation number as 0. Clear this point? Is the point clear for everyone? Now, the third point about the oxidation number is, oxidation number of hydrogen is taken as +1. Hydrogen is taken as +1, right? But there is an exception, which means that whenever we are considering the metal hydrides, for example, lithium hydride, right? Lithium is a metal, it forms hydride with hydrogen atoms form lithium hydride. What will be the oxidation number or state of hydrogen atom in the case of lithium hydride? Lithium is already an alkali metal, right? It has the oxidation state of +1. Then according to our rule, this has the oxidation state of +1. According to our rule, the algebraic sum of all the oxidation number of all the atoms should be 0, right? So if I am taking plus 1 here, plus hydrogen we have to calculate, right? So we are taking it as x is equal to 0. Otherwise we can take it as x is equal to minus 1. Clear? Which means in the case of all the metal hydrates, hydrogen exhibits oxidation state of minus 1 for hydrates. This point you have to be keep in your mind. Clear? Rather than we will be explaining these chapters in the next sessions. Right, we will be explaining the case of hydrocarbons chapter, right? Chemical properties of alkenes, their reactions and everything we will be discussing on the chapter hydrocarbons. Okay? Now, the next point is that oxidation number of halogens are taken as minus 1. What do you mean by halogens? Already discussed, right, in the periodic table. The group 17 elements like fluorine, chlorine, bromine, iodine, astatine, right? These elements are known as the halogens. In the case of halogens, the oxidation number always taken as minus 1, right? Next one, whenever we are considering the oxygen atom, the oxidation number of oxygen is generally taken as minus 2. Right? Oxygen have the oxidation number of minus 2. Again, as Markovnikov rule also we will be explaining the organic chemistry chapters. Most probably in the hydrocarbons. Don't worry, we will discuss everything. Okay, oxidation number of oxygen is generally taken as minus 2. But some exceptions are again there. If we are considering peroxide bonds or superoxides or oxofluorides, oxygen will show various oxidation number, right? For example, if I am taking H2O2, right? That is the peroxide. We know the oxidation state of hydrogen is 2, which means 2 plus 2x is equal to 0 or x is equal to minus 1, right? X is equal to minus 1. In the case of peroxides, the oxidation state of oxygen is always minus 1. Yes. Now, if we are considering the superoxides, that is KO2, potassium is an alkali metal, right? So, it has the oxidation number of plus 1. So, if we am taking the algebraic sum as 0, we will get the oxidation state of oxygen as how much it will be? X is equal to minus 1 by 2, right? 2 oxygen are present here, 1 plus 2x equal to 0 or 2x is equal to minus 1 or x is equal to minus 1 by 2, right? Mahbub, is the thing clear? How we are calculating the oxidation number? In the case of superoxide, the oxidation number of oxygen should be minus 1 by 2. Clear? Now, if we are considering another molecule, that is oxofluorides, if I am taking here OF2, fluorine is halogen, right? Fluorine is halogen having the oxidation number of minus 1. So, x minus 2 is equal to 0 or x is equal to plus 2, which means that oxidation number of oxygen in the case of oxyfluorides is taken as plus 2. Clear? Radhan, don't worry, we will explain all these topics in this particular session, that is percentile booster batch. No need to worry, right? Now, here is some practice questions for you. You have to find out the oxidation states of underlying atoms. Just do these questions along with me, which means practice become more perfect, right? Practice makes you more perfect. So just do these calculations. Here you can see that in the case of first element, that is carbon dioxide, here you have to find out the oxidation number of underlying atoms, right? So here you can see that carbon is the underlying atom here. You have to find out the oxidation state of carbon in the case of carbon dioxide molecule. Then please give me the answer. Four, right? Because oxygen have an oxidation number of -2. Here 2 oxygens are present, which means that we will be taking the algebraic sum as 0, which means carbon we have to be calculated. So we are taking x here. Okay, x here. Then we are just adding the oxidation numbers of oxygen here. 2 into -2, it is -4. So I am simply writing here x plus -4, or x minus 4 is equal to 0, or x is equal to +4. Clear? Yes. Yeah, you are correct, Sudha. Sudha Rani, yeah. Then what about the second one? Here is the next molecule, NH2OH. Here the underlying atom is nitrogen. Find out the oxidation state of nitrogen atom in the case of NH2OH molecule. Okay, you can do all these things and give me the answers one by one. What will be the answer of second one? What will be the answer of third one? Okay, what will be the answer? Okay, let's take the second question. Here, underlined atom is nitrogen, right? So, you have to find out the oxidation number of nitrogen here. So, x plus 2 means 2 hydrogen atom having the oxidation state of 1 each, right? 2 into 1, 2 plus, then either you can take it as whole minus charge, otherwise you can take it as -2 plus 1. Both are same, right? So, I am taking simply here oxygen is -2 plus 1 hydrogen, that is +1. While calculating this, you can get that x plus 1 is equal to 0, or x is equal to -1, which means that oxidation number of nitrogen atom in this particular compound is -1. Clear? Okay, many of you are giving the answers in the comment box. So happy to that. Okay, what about the third question? Okay, I will explain the third one first. Here, the underlined atom is sulfur, right? So, we are just taking here sulfur, we have to calculate. So, it is taken as x. Then, 4 oxygen atom, it is 4 into -2, that is -8. And I have already discussed that whenever we are having a polyatomic ion, here the algebraic sum of all the oxidation number of all the atoms should be equal to the simple charge on it, right? Which means that here x minus 8 is equal to -2, or x is equal to -2 plus 8, that is equal to +6. Clear? Is there any confusion? The third question, I am explaining once again. For example, sulfur you have to be calculated. Oxygen, 4 oxygen atoms are present, right? 4 into minus 2 minus 8. X minus 8 is equal to minus 2, which is the charge on this particular ion, which means x minus 8 is equal to minus 2. This minus 2, then this minus 8 will goes to the right side, which will form minus 2 plus 8, which means 8 minus 2 is equal to plus 6. Clear? Or any doubt? Can we move to the next example? Here are more examples for you. The next question is, the molecule is given as, or the compound is given as K4FeCN6. What will be the oxidation state of underlying atom, that is ion here, Okay, what will be the answer here in the case of iron? Hi Akshay, good evening. Okay, what will be the oxidation state of iron in this particular compound? Two, right? Yes. If you are considering this molecule, you can say that potassium, alkali metal, right? It has the oxidation number of plus 4. 4 potassium are present here, so we are taking plus 4 here. Then iron we have to be calculated, taken as X. Then Cn means cyanide ion. It has the oxidation number of, or charge of, minus 1. So here 6 Cn minus ions are present here. So it will be taken as 4 plus X minus 6 is equal to 0. That is the algebraic sum. Which means while calculating, you will get the oxidation number of iron as plus 2. Clear? Yes, what will be the oxidation state of second compound? I mean manganese in the KMnO4. Yes, plus 7. Akshay, yeah, right. Mahaboob, yeah, all are right. Yes. Do I need to explain? Then what about the third one? Here the underlying atom is chromium. We have to find out the oxidation number of chromium. Six, right? Hi Shivraj. Is the thing clear for everyone? How we can calculate the oxidation number of atoms in particular compound? Is it clear? Now let us move to some special case. Let us move some special case. Here, two different compounds I have given. While calculating the general method, you will get the wrong oxidation number, right? If you am taking in the case of chromium, what will be the oxidation number of chromium in this particular compound by using the general method? Just calculate that. Ratan, don't worry, we will be discussing the oxidation and reduction topic detail in the next slide. I will explain everything. No need to worry. Yes, 10, right? Simply, if I am taking x minus 10, that is equal to 0. Which means x is equal to plus 10. But in actual practice, this is not the correct answer. This is wrong. Why? This is a special case in which we have to consider the structure of this particular compound, right? So I am writing here. This is the particular structure of this particular compound. This is a butterfly structure. Okay, butterfly structure, which means that these are the peroxide linkage. These are the peroxide linkages. There is a point you have to note that whenever I am taking two atoms, right, A, B, going to be a molecule. If I am saying that B is more electronegative than A, which means that electronegativity I have discussed, right? It means the electronegativity means the its capability of attracting the shared pair of electrons towards its, right? Which means B is more electronegative than means it has more negative charge. So if I am taking here B has a negative charge of -1, then by losing electron A will possess +1 charge, right? Simply we can say that if whenever the electronegativity difference is there in between two atoms, we can say that which one have the more electronegativity shows the -1 oxidation state. Is it clear? Is the point clear? Just let me know, then only I can explain the structure. Okay, I hope the point was clear for everyone. Now let me explain here. We know that the oxygen is more electronegative than chromium, right? We have already studied about the periodic trend of this electronegativity. So if I am taking oxygen is here, as according to this rule, oxygen is more electronegative than chromium, right? Which means it will possess -1 charge because it is attracting the electron pairs towards it, right? So that chromium experiences +1 charge. Is it clear? It experiences +1 charge. It is experiencing +1 charge. Clear? Okay. Now again, if we consider the next oxygen molecule, what will be the charge on this chromium atom? Again, chromium and oxygen electronegativity difference is there. Oxygen is more electronegative. It will form -1 charge, so that chromium experiences +1 charge by this oxygen. Similarly, here also -1, +1. Here also -1, +1, right? If there is 2 bond, what will be the total charge on this chromium atom experienced by this oxygen atom? I have already discussed that for one bond, it is +1, -1. If I am taking 2 bond, what will be the charge? Oxygen experiencing -2 charge, right? Which means chromium experiencing +2 charge. So that in total, the oxidation number of chromium in this particular structure is sum of these all atoms, right? Sum of the oxidation numbers of all these atoms, which means +2 +1 +1 +1 +1, that is equal to 6. Is it clear? Yes. Now let me move to the next compound, that is CaOCl2. If anyone knows the chemical name of this particular compound, CaOCl2. Anyone? Yes, bleaching powder, right. CaCl2 means bleaching powder, and the structure is now please explain what will be the charge on this particular oxidation number of particular atoms. Just check about the electronegativity difference, which one have the more electronegativity, then find out the oxidation number of particular atoms. Okay, let us check. If you am considering these bonds Ca and Cl, which one is more electronegative? Calcium or chlorine? Chlorine is more electronegative, right? Which means it will acquires -1 charge and calcium will acquires +1 charge because of this bond. Then what will be here? Again, calcium is less electronegative than oxygen. It will acquires -1 charge here due to this calcium. Again, it will acquires +1 charge. Then what about OCl bond? Chlorine or oxygen? Which one is more electronegative? Is it clear? Because of the electronegativity difference, oxygen will acquire -1 charge and chlorine will acquire +1 charge. In total, yes. In total, oxygen will acquire of -2 charge. Some of these charges, right? It will become -2. And for chlorine, it is +1. For this particular chlorine, it is -1. Then for calcium, it is sum total of +2. Sum total of +2. Clear? Is it clear? Yes, fine. Now, we have already discussed about the oxidation number, how to calculate the oxidation number of particular atoms in a compound. Now, let me explain the basics of redox reaction, that is oxidation as well as reduction reaction, right? So, in this particular topic, we will be discussing about the more different concepts like classical concept, oxidation number concept and electronic concept. Let me first move to the first concept, that is classical concept. Okay, as you can see here, this is the classical concept, the first concept of explaining oxidation and reduction. According to this classical theory or classical concept, we can say that simply the oxidation is the addition of oxygen. Oxidation is the addition of oxygen. As you can see here in this particular example, S plus O2 gives SO2, which means oxygen is adding, right? Sulfur is adding oxygen to form sulfur dioxide. This is an example of oxidation reaction. Clear? Then, again we can divide or classify oxidation according to the terms of hydrogen. The removal of hydrogen or addition of any electronegative element or removal of an electropositive element is also known as oxidation. I will explain with example. For example, if I am taking this particular example, right? H2S plus Cl2 gives 2HCl plus S, which means that you can see that here the hydrogen is removing, right? H2 is converting to sulfur by removing one hydrogen, which means that the removal of hydrogen is taken as oxidation reaction. Otherwise, we can also say that the addition of an electronegative element. Chlorine is electronegative, right? Whenever we are adding chlorine to this particular compound, it will convert it into 2HCl plus S, which means that addition of electronegative element is also considered as the oxidation. Clear? Hi, my name is Surya. Hi Ravikumar, hello. Is it clear? Yes, fine. Now, we have to discuss what you mean by reduction according to this classical concept. Just opposite of the oxidation, right? Which means we have divided that or discussed that oxidation means the addition of oxygen. Whenever we are taking the next one, this is the just opposite, which means removal of oxygen is known as the reduction. Removal of oxygen is known as the reduction. Otherwise, we can say that addition of hydrogen is also taken as the reduction. Here is the first example for you. CO plus C gives CO plus CO. What will happen here? In terms of oxygen, here the copper oxide is removing oxygen atom to form copper, right? Which means removal of oxygen is also known as the reduction. Then in terms of hydrogen, we can say that C2H4, our ethene molecule, right? Whenever it is adding hydrogen molecule, it will form ethane molecule, which means that addition of hydrogen is also taken as reduction. Is it clear? Is the classical concept is clear for everyone? Yes. Now let me move to the next concept, that is the oxidation number concept, right? We have already discussed about the oxidation number. According to the oxidation number concept, we can divide the oxidation as well as reduction into two parts. That is, if there is an increase in the oxidation number, we will consider the reaction as an oxidation. If the oxidation number is increases, it will consider as an oxidation reaction. And if the oxidation number is decreasing, it will consider as a reduction reaction. Clear? Let us take one example here. For example, ZnO plus C gives Zn plus CO. Just calculate the oxidation number. What will be the oxidation number here? Carbon in its elemental form, right? It has the oxidation number of 0. Again, zinc is also having 0. For carbon monoxide, it is plus 2 and minus 2, right? Plus 2 and minus 2. Or you can say that here zinc is changing its oxidation number from plus 2 to 0, which means that decrease in oxidation number is termed as the reduction. Here zinc is get reduced. Then what about the carbon? It will change its oxidation number from carbon is changing its oxidation number from 0 to plus 2, which means oxidation number is increasing, it undergoes oxidation. Clear? Okay, this is about the oxidation number concept. Now let me move to the electronic concept of oxidation and reduction. As you can see here, the loss of electrons are taken as oxidation. Similarly, the gain of electrons are taken as reduction. An example is given here. Whenever we are converting the zinc element or zinc atom to zinc plus 2 ion, it will lose 2 electrons. We will discuss in the detail in your chapter electrochemistry in the galvanic cell. Then you can see here that Al3 plus will convert it into its aluminum element by gaining 3 electrons, which means this is an example of reduction and this is an example of oxidation. Is it clear? Is it clear? So far we have discussed the 3 concepts of oxidation and reduction. I hope it was clear for everyone. Now let me move to the most important topic, that is oxidizing agent and reducing agent. As we already know that while changing the oxidation number, it will form oxidation or reduction, right? So if I am taking a reagent which can increase the oxidation number, what do you mean by increasing oxidation number? It undergoes oxidation or reduction. Amrit, which point you want to repeat? Electronic concept. Okay, I will explain the electronic concept once again. You can simply say that oxidation is the loss of electrons. For example, you can see here, in the case of zinc, it will form zinc plus 2 ion by losing 2 electrons. Similarly, you can take it as reduction as gain of electrons. Here you can see that aluminum will convert into plus 3 ion to simple aluminum by gaining 3 electrons. Clear? Okay, what do you mean by the increase in the oxidation number? Oxidation, right? So that we can say that an oxidation agent is a reagent that will help in the oxidation by undergoing reduction itself. The reagent itself undergo reduction, but it will help in the oxidation. Such reagents are known as oxidizing agent or oxidants. Clear? Similarly, we can define reducing agents also. It will help in lowers the oxidation number. What do you mean by lowering oxidation number? Reduction, right? So, the reagents that helps in reduction by itself undergoing oxidation. By itself undergoing oxidation are known as the reducing agent or reductants. Clear? Now I have given an example for you. Just calculate the oxidation number, then find out which one is the oxidant and reductant in this particular example. Just calculate the oxidation numbers here. Okay, which one will be the oxidizing agent and reducing agent here? What will be the answer? Is it clear? Here you can see that copper is changing its oxidation state from +1 to 0, which means it undergoes reduction, so that it will consider as an oxidizing agent. I will written as OA. Similarly, if you are considering the second molecule here, sulfur is changing its oxidation state from -2 to +2, which means it undergo oxidation, right? So it will be a reducing agent here. Clear? Is it clear? So far we have discussed the basics of redox reaction, that we have discussed about the oxidation number. Then finally we move into the oxidation and reduction. They are different concepts including classical concepts, electronic concepts and oxidation number concept. And also we have discussed about the oxidizing agent and reducing agent. Now here is some practice questions for you. Just give me the answer. The first question is oxidation number of carbon in CH2Cl2. What will be the answer? What will be the oxidation number of carbon in CH2Cl2? What will be the answer? Subaraj 2. Let us check. Is it clear? How it became 0? Option 4 will be the correct answer here. You have to just calculate the, yes. You have to just calculate the oxidation number of carbon here. Here carbon we will take as X. For 2 hydrogen, 2 into 1, that is plus 2. Then for 2 chlorine atoms, 1 chlorine atom possesses minus 1 charge. For 2 chlorine atom, it is minus 2. Then X plus 2 minus 2 is equal to 0, which is the algebraic sum. Then X is equal to 0. Clear? Can we move to the next question? Okay, here is the next question for you. Again, to calculate the oxygen state. Here different compounds are given here, in which sulfur is the major component here. You have to find out the compound that have sulfur in which have least oxidation state. Least oxidation state. So that you have to identify the oxidation state of each of the compound. Sulfur in each of the compound. Then find out the one which is having the least value. Which will be the answer? Okay, what will be the answer? First one, right? Having the least oxidation state of +1, which means option A will be, option 1 will be the correct answer. Clear? Now, here is the next question. Find out the oxidation state of nickel in nickel carbonyl. Okay, option D. What about others? Yes, correct answer is option D, that is 0. As we can know that in the case of carbonyl compounds, the carbon is a neutral molecule. It has a charge of 0, right? It has a charge of 0. So in total, whenever we are calculating the oxidation number, you can say that nickel having the oxidation number of 0 in the case of nickel carbonyl compound. Clear? Option 4, 0 is the correct answer. Okay, here is the next question for you. The oxidation number of potassium in K2O, K2O2 and KO2 respectively are. 3 different compounds are given here, 3 different oxides are given here. You have to find out the oxidation number of potassium in each of the compounds. What will be the answer? These are the 3 different oxides. Find out the oxidation number of potassium. Not oxygen, potassium. What will be the answer? Subharaj, option B. What about others? Is there any other options? Yes, option 2 or B is the correct answer. Here the point you have to note it that whenever you are giving any type of oxide, this is the alkali metal, right? Potassium is the alkali metal. In every compound, alkali metal shows only +1 oxidation state. Clear? Same potassium here +1. While calculating also you will get the answer as +1 only. So simply you can answer this question as +1 +1 +1, which is the general oxidation state of potassium, that is the alkali metal. Option B will be the correct answer. Clear? Then the next question is oxidation number of phosphorus is +3 in which of these following compounds? Which one will be the correct answer? Yes, option A, right? H3PO3 having the oxidation number of 3. First, you have to calculate the oxidation number of phosphorus in each of the four compounds, then find out the one which is having the oxygen state of +3. Here, the first one, H3PO3 is the correct answer. Clear? Now, same repeated question, that the oxidation state of nickel in nickel carbonyl, that is 0. Then, okay, a reaction is given here. You have to identify what is the role of MnO2 in this particular reaction, whether it is acting as oxidizing agent, reducing agent, or both oxidant as well as reductant. How you can approach this question? First, you have to find out the oxidation number of each of the atom present in this particular compound. Then find out the which one having oxidation, that will be the reducing agent, and find out the which one having reduction, that will be the oxidizing agent, right? What is the role of MnO2? Yes, option A, right? It will act as the oxidizing agent, which means that it helps in the oxidation or itself undergo reduction, right? It changes its oxygen state from +4 to +2, which means it undergo reduction, so that it will be taken as the oxidizing agent. Clear? Again, here is the next question for you. Find out the role of water molecule in this particular reaction. Find out the oxidation number first. Carbon in its elemental form having 0. Then for hydrogen it is +1. For oxygen it is -2 in the case of water molecule. Again in the case of carbon it is +2 and oxygen is -2. Hydrogen is in the elemental form. It will show 0 oxidations, right? What will happen here? Reduction, right? Simply it can say that this is the removal of oxygen, right? Water molecule is removing oxygen to form hydrogen atom. Removal of oxygen means reduction, right? So it will act as the oxidizing agent. Otherwise, this is a decrease in oxidation number or it undergo reduction. Simply we can say that water is act as an oxidizing agent here. Clear? Then the next question is find out the increasing order of oxidation states of nitrogen in these compounds. Compounds are given as NO, NO2, N2, N2O and NO3 minus. Find out the increasing order. First you have to calculate the oxidation number of nitrogen in these particular compounds, then find out the increasing order. Okay, what will be the order? We have to find out the increasing order, right? So start from the least one. So if I am taking the least one, this is N2O, right? So for N2O, then what is the next one? NO, right? Having the oxidation number of +2. NO, then NO2, then the last one NO3 minus, having the oxidation number of +5. Is it clear? Is it clear? We have to find out the increasing order. So we have to start from the least one, that is +1 N2O, then +2 NO, then +4 NO2, then last one +5 NO3 minus. Is it clear? Then what about this question? Give me the answer. A reaction is given here. You have to find out the role of sulfuric acid in it. What will be the answer? Oxidizing agent, right? Sulfuric acid here undergoes reduction, which means this is the sulfuric acid will undergo reduction, so it will act as the oxidizing agent. Clear? Clear? Okay, fine. That's all from my side for today. I hope I have covered the basics of redox reaction. We have started with the oxidation number calculation. I hope you have given have the idea about how to calculate the oxidation number of particular atoms or elements in a particular molecule. Then we have discussed about the oxidation according to different concepts like classical concept, electronic concept and oxidation number concept. Finally, we have moved to the oxidizing agent as well as reducing agent. Then we have practiced some questions also. I hope you guys enjoyed the session. Don't forget to hit the like button. Then maximum share this particular session to your friends also. Then do subscribe our channel for more updates. Okay, fine. Let us see you in the next class. I mean tomorrow, the same time from 8 to 9. I will be coming with the next session. We have discussing about the types of redox reactions here. Till then, bye-bye. Good night, all of you.